Last time we looked at current, voltage, resistance, and Ohm's law. This episode continues from there. Turn on a receiver and the antenna may be picking up many signals at once. Yet the speaker gives you the station you've tuned to. How does the circuit choose? The answer begins with three ordinary components: a resistor, a capacitor, and an inductor, though it's how two of them team up that does the choosing. This series is going through the ASOC syllabus step by step. Subscribe and tap the bell so you don't miss the next part. A resistor is a component made to provide a specific resistance. Its job is to limit current, divide voltage, or set operating conditions in a circuit. A resistor converts some electrical energy into heat. In normal use, this heat is small. But if too much current flows, the resistor can overheat. Resistors are marked with values. Many traditional resistors use colored bands. These bands show the resistance value and tolerance. A simple phrase helps many people remember the color order. B.B. Roy of Great Britain had a very good wife wearing gold-silver necklace. Each first letter gives a color, in order: black, brown, red, orange, yellow, green, blue, violet, gray, white for the digits 0 to 9, then gold and silver for tolerance. For example, a resistor may be 100 ohms, 1 kilo ohm, or 10 kilo ohms. In circuit diagrams, resistors are shown with a resistor symbol and labeled with their value. For amateur radio, resistors are found almost everywhere: in audio circuits, RF circuits, biasing networks, filters, meters, and test loads. A capacitor is a component that stores electrical energy in an electric field. It has two conducting plates separated by an insulating material. When voltage is applied, charge builds up on the plates. That stored energy can be released back into the circuit. The unit of capacitance is the farad, written as F. The farad is named after Michael Faraday. In practical electronics, 1 farad is a large value, so capacitors are often measured in microfarads, nanofarads, or picofarads. Capacitors are used for many purposes: smoothing power supplies, blocking direct current, passing alternating signals, and tuning circuits. In radio, capacitors are very important because they help select and control frequencies. An inductor is a component that stores energy in a magnetic field. It is usually made from a coil of wire. When current flows through the coil, a magnetic field forms around it. If the current changes, the magnetic field also changes, and the inductor opposes that change. The unit of inductance is the Henry, written as H. The Henry is named after Joseph Henry. This is easy to mix up, so keep it separate. Capacitance is measured in farads, named after Faraday. Inductance is measured in henries, named after Joseph Henry. In radio circuits, inductors are used in filters, tuning circuits, oscillators, and matching networks. A capacitor stores energy in an electric field. An inductor stores energy in a magnetic field. When they are used together, they can form a tuned circuit. A tuned circuit responds strongly to one frequency or a small range of frequencies. This is important in radio because an antenna may receive many signals at the same time. The receiver has to select the wanted signal and reject the others. Tuned circuits help with that selection. This idea is called resonance. A full radio receiver is more complex than one capacitor and one inductor, but the basic idea starts here. Electronic components can be arranged so that one frequency is selected more strongly than others. That is why basic components are not just exam facts. They are part of how radios actually work. There is one more basic idea connected to current, voltage, and resistance: power. Electrical power tells us how fast electrical energy is being used or converted. The unit of power is the watt, written as W. A common formula is P is equal to V multiplied by I. Power is equal to voltage multiplied by current. For example, if a circuit uses 12 volts and 2 amperes, the power is 12 multiplied by 2 is equal to 24 watts. Power matters because components have limits. A resistor may be rated for a quarter watt, half watt, 1 watt, or more. If the circuit forces it to handle more power than it is rated for, it can overheat. In amateur radio, power is also important because transmitters are rated in watts. A handheld radio may transmit at a few watts. A base station may transmit at much higher power, depending on the license and regulations. So current, voltage, resistance, and power are connected ideas. Basic electricity also teaches safety. Never touch exposed conductors in a live circuit. Never work on mains wiring unless trained and authorized. Never short the terminals of a battery. Never use a power supply, wire, or connector beyond its rating. Even low-voltage systems can become dangerous if they can supply high current. A short circuit can heat wires quickly and damage equipment. In radio work, good safety habits start early. Switch off power before changing connections, use fuses where needed, check polarity, and use the correct rating for cables and components. The exam tests these ideas because they matter in real operation. One quick revision. A resistor limits current. A capacitor stores energy in an electric field. An inductor stores energy in a magnetic field. Together, a capacitor and inductor can favor one frequency over others. Power tells us how quickly energy is used, so ratings and safe connections matter. Subscribe and tap the bell to stay in touch. Suggestions and comments are welcome below. This is Calling CQ. See you on the air.